concentrate on too many things. We can only concentrate on a few things at a time, for you, your team, and the whole company. Okay? So that's why it makes more sense to create small increment, small chunk, so you can focus your attention on a small chunk. Make it right. So this is more likely the real situation you're going to see in a software development project. You're going to do requirement analysis, design, implementation, and test all the way. Okay? Day one of the project. You're doing all these things. Okay? Just the amount of work you probably are doing with regarding to requirement is heavier toward the end, to front of the project, beginning of the project, more testing and implementation toward the end of the project. Okay? So this, you can imagine this is for our project. We have 8 weeks. Okay? At the beginning, you are going to have a lot of work in the beginning, first 2 weeks. Okay? We have 8 weeks. If we imagine we do that 4 chunks, 2 weeks as a sprint. For the first 2 weeks, you are actually going to be heavy on requirement analysis and design, less in coding and testing. Okay? As you move on, you can see that you're going to spend more time on design because you understand requirement now better, right? Then you'll start ramping up your implementation and testing. In the third sprint, you are, okay, I'm now settled on my design. I'm actually spending most of my time doing implementation and testing. In the last sprint, you are ramping down the implementation. You're making design changes, but not too many. And you're changing your code, but a lot more in validation because you are ready to deliver your product to your customer. Okay? So this is actually a more effective way for us to do project. This is going to be true for our own class project, and also highly likely going to be a situation you face in a real project. Okay? You are actually going to do all 5 things at any stage. You have to do them, but just that the focus is slightly different. Okay? Here you spend a lot of time figuring out the requirement because you don't know things well at that point, but you already need to do some implementation to demonstrate to your customer you are actually getting to the concept and being able to deliver the first prototype for them to try it out. The reason you give the first prototype is actually the prototype will help you gather further information back from your customer so that you can use that to refine your own design. Okay? So as you gather more information, you start spending more time on design, and then it's stabilized. Your customer are not making so many design changes. You can finally focus more on the implementation side and testing. Once that's done, so you guys are happy with all the features, then you have to wrap up your project by doing a lot of testing, alpha testing, beta testing, acceptance testing to deliver your product to your customer. Go ahead.
What about, I guess, would it be part of the design if you want to consider how long it's going to take to write certain features? Would that be part of the design workflow or the design part of this?
This is going to be the project management plan we'll touch on. So I know it's not easy to quantify how much time you need to write certain module. It's highly dependent on the feature. However, that's part of your project manager responsibility. Okay? So essentially, as a team, say you are the project manager. So first of all, you have to differentiate the difference between product manager and project manager. Okay? The product manager is really the guy responsible about how this product will look, how it will shape up to be, the customer will need to use. Okay? And project manager is really putting putting the task to each individual programmer and tester so that they are fully loaded, okay, to execute the task. So the project manager has to work with the teammate and team member to actually figure out, actually get a good sense of, for any given module. If I'm the project manager, you're the programmer, then we need to sit down and say, okay, based on our previous experience, for this module, how much time we need. Typically, right now, to measure this is going to be in the feature point. It can be in a straightforward way I could use, in a simple way, say, what's your estimate for hours? Okay? Not even days, really work hours. How many hours you need to finish this particular feature, this code. So then, at the beginning, we'll be way off, right? Because we are not experienced with each other, and we don't have experience on the project. And gradually, in a later sprint, we'll have much better measurement of time. So that is also one of the difficulty in software engineering, which is most of us actually are doing a one-off project. So basically, we're doing new project every time, essentially. No two websites is the same. No two information system is the same. And actually, we are getting new feature all the time. So this is very different from profession like accountant, right? Accountant, they actually do it by hours. Actually, they can relatively easy to manage how big a tax return, how many tax return you can finish within a day. They have a fairly good estimate. For us, because the tax return are the same, basically, right? You just need to plug in the numbers, it will come out with all the results. Not for us, right? So to figure that out, really is going to be a negotiation of some sort, or measurement of some sort, between the project manager and the developer. But sometimes you are the project manager and the developer, then essentially you are negotiating with yourself and say, how many hours workload I put on this task. Okay? And this is also a measurement of task. All right? So why they are giving you a time limit to finish a certain task? Because they want to see how much you finish within that time, right? Then they can use this to use a rough estimate, coding speed and that kind of thing to measure your progress, right? So all about metrics. But that's how typically it's going to work. All right? So we already talked about that. No matter what, you have to do those 5 steps: requirement, analysis, design, implementation, and testing. No escape. All right? No matter you're going to do the project a year, you're going to do the project a day, you're going to do the project a month, you have to do requirement, analysis, design, implementation, and testing. To simplify it more, it's just going to be requirement, design, implementation, test. If you're lucky, you got to maintain your code. If you're not lucky, your code is out. Yeah, not worse, even worse with maintenance, then yeah, that code probably disappeared. Okay? So essentially the 4 things, critical things: requirement, design, implementation, and test. Here we are touching on test, implementation. Actually, because this problem is so simple, I only have one liner for you. So essentially the requirement job is very little. But you do have a design job, right? You are designing the test environment. You're designing the interface of your class. You're designing what attributes you have, what method you have. This is called detailed design because you are designing one single object. Okay? The process of figure out how many objects, classes you have in your system, typically called high-level design or analysis. Okay? So essentially your job is to take a piece of English spec, identify how many object classes you need in your system, give each class the attribute and method, get them implemented, hopefully it's going to work. Okay? That is for anybody, that will be the process. How exactly you do that actually you have to form your own small process. Okay, but we are going to talk about how typically people will do that. All right, so that's why you can see that within each increment, we actually here it's not, so within that, for instance, if we look at the four increment we will do, I mean, so within each increment, you actually have to loop that many times, right? So, I mean, software engineering, basically, to me, a critical thing for us, I mean, as the instructor, is to help you relate software development tasks to your daily activities, right? So for instance, just look at this iteration. This is how we prepare a test. You go over the material several times. If I read the textbook one chapter, the first time I read it, I don't understand. I go back to read it a second time. I read it enough times, probably I understand the concept. Same deal here. You work on this particular increment. First time, well, you're not getting it done. Okay, let's do it the second time. Do it third time, adding a little bit more, and eventually it's acceptable to your customer. Okay? Same thing with just how we prepare, how we study. So a lot of software engineering is actually map your life skills. For instance, your ability to do cost-benefit analysis onto software project cost-benefit analysis. Right? So you guys are very good at do the minimum work for a class and get an A or B. Right? That is the same thing with software engineering project. You want to do the minimum work and get paid, right?
Yeah, I tried that with one of my earlier computer science classes, but they changed the requirements by removing the final at the last minute. So I failed.
That is why. So in real life project, that's going to happen as well. Your customer is moving the goalpost. You're toast, right? So that's why you never commit such a long time to it until you actually figure out what exactly they need. Okay, that's exactly what I'm saying. You're actually mapping your life skill to how you are going to manage a software engineering project. Okay, using your own way. Okay, you already have the skill set. Just that you need to map. Okay, in software engineering we need to do this. Okay, this is going to be my approach. Okay. So this is for our major part of our class is for you to think about how you apply your own skill to solve a problem. All right. The unified process is actually it's one reference process. This is just a reference. So it's not going to be the only process. It just provides you some fundamental things like how you represent design, how you represent requirement, how you represent test, how you represent implementation, and so forth. Eventually, you can do your job. Okay, we'll spend some time on this later on. All right. So workflow, as we know, we have mentioned this many times. Requirement is to figure out what needs to be done. Okay. Requirement stage is for you to list the things need to be done. Okay? So this is very much like you make a plan of study for the week or for the day. Okay? These items need to be taken care of. This is like you make a grocery shopping list as well. Okay? I need to knock all these things off today, otherwise I'm in some sort of trouble. I don't have things in my fridge. I don't have clothes to wear tomorrow because I haven't washed anything. So, or I haven't bought all the food and milk, so I'm going hungry for tomorrow morning. Right? So essentially, you need to make that plan. Requirement is a stage that you determine what exactly the client needs, and basically that's a good indication of what you need to do. Okay? What you need to do. They need this feature. Right? For instance, we mentioned last time, your client need a app to pull weather information for a particular location. Okay? So in that case, so do you need to know at this stage how exactly you are going to do the app? No. But you know what exactly the app is supposed to do. Guess what? That's the requirement. That is the requirement. Okay? I don't care what kind of code, what zombie code is in that app. I don't care. But I know from outside it looks glory and shiny. It's pulling down the weather data and showing me in a great screen. Okay? That is going to be my requirement. That is requirement. We're not going to the system yet. We're watching, looking, measure the system from outside. For instance, I know this box is toggle. I can change. For instance, I'm going to say, oh, I don't want you guys to see the slide anymore. I can have that functionality, and I can switch to a dial cam, which doesn't work. I go back to a computer, right? This thing exists here because somebody already did it, right? But as a requirement, if I give you this requirement, actually, I'm not looking into the box. I don't know what's in the box. But I will tell you what button need to be there and what need to be happening when I push the button. Okay? I'm not going into the system, all right? I'm just looking at the system from outside. That is requirement. Are we clear? Okay? If you're not going to a system, you're just going to go look at the system from outside and see what this system can do for me, can do for my customer. That is requirement. Okay? Requirement has nothing to do with what exactly is in the system. That's unfortunately, your job. Okay? But for your customer, I just want to be here, have this box we use for my lecture. I don't care how you implement this. So that is requirement. Okay? So what exactly is going to be analysis flow? All right? Here, actually, I'm going to say we know the requirement. Now we are actually going to understand the requirements so we can take this box apart. And now we can point to, okay, we need the module 1, we need the module 2, we need the module 3, we need a bunch of classes in this program. Okay? At this stage, I'm not going to look at each line of code. What I'm looking at is a number of modules interacting with each other. That is high-level design and also so-called analysis stage. When you look at into the system, but only look at from a module point of view, but not inside the module. That's called high-level design and analysis. Go ahead.
I feel like, especially in the analysis workflow, you're going to run into, perhaps, depending on how detailed the requirements are, you're going to run into ambiguities in the requirement and have to go back to the client with additional questions. Is that
Exactly.
common?
Very common.
Yeah.
So that's why you are never going to be able to say, I'm done with my requirement, I'm done with my analysis. That is not the case in software engineering project. You always have to do requirement, you always have to do high-level design, detailed design all the time, because your customer can actually come back and say, I want this change. Ambiguity can be something that you just say, oh, I don't know how to solve this problem. Guess what? I'm going to punt the ball down the road and I'm going to worry about it later. Isn't that one of your great skill set, right? Just delay and procrastinate until it becomes so clear, I'm not going to do it. Right? How many of you already started on my project? Hopefully not. That would be really strange, right? I haven't given you anything, and how could you start my project? Right? That's the point. When you making your design, making your requirement, you can only make the requirement and design on things that you're already clear about. If I haven't give you that or it's so ambiguous, are you going to commit your engineering time? No, you should not. That's why it's called incremental development. I only commit my engineering work for 2 weeks for this project. I'm only committing 2 engineers because I don't have more work for the 3rd engineer sitting here. Guess what? I'm not going to pay him. Not going to put him on the project because I'm not getting my money back. Right? So that is high-level design. Okay. Design flow. This is it. Okay. Now we know the class. That's the module. But we need to know exactly how many attributes this guy has. I mean, how many methods. If you don't have that, okay, how can you write that class down? Implement. If you don't know, I mean, that will never be a class. If you don't have number of attributes and method nailed down. That's your detailed design process. And also, you're coming up with the algorithm for each method. When I say algorithm, you may say, oh, what exactly is the algorithm in the linked list? Okay, I'm just return the first element. Guess what? Algorithm can be very simple, right? I'm just return the content of the first element if that point reference is not null. Okay, that is my algorithm, right? It doesn't have to be a depth first search kind of algorithm to be called an algorithm. Actually, all the code I need to implement that method is my algorithm. That is our detailed design process. Implementation, very straightforward. Write that in Java, get it compiled. Okay? If that's happening, well, guess what? You're going to testing. Run the code, review the code to make sure that it indeed fulfills the requirement. Isn't that what we do here?